So we're continuing our discussion about equivalency. So we're going to get into a little bit more complex equivalency. So in this lesson, we will continue to explore expressions that are equivalent. We'll be primarily sticking to linear expressions. We'll get to quadratic expressions where it's raised to the second power. We'll also be talking about those as well. Recall that two expressions are equivalent if they return equal values when values are substituted into them. So let's consider that product x minus 2 times the quantity of x plus 5. Is it equivalent to one of the expressions below? And to determine that, we're going to substitute x equals 3 into all three of those expressions to see which one is equivalent to the x minus 2, x plus 5. So let me take a look at substituting 3. So 3 minus 2 times 3 plus 5. Evaluating that, we end up with 1 times 8, which is 8. Okay? So let's figure out which one of these two expressions is equal to 8 when we put 3 into it. So looking at the second one, if we take 3 and we square it, minus 10, that's 9 minus 10, which is negative 1. We can start to see that that's not going to be our 1, so hopefully this is going to be the 1. So, oops, I probably should change some color on that one. 3 squared, that's kind of a crazy looking 3. I'm using a new stylus that I just got on Friday, so this is kind of new to me working through this. So 3 squared plus 3 times 3 minus 10. So 9 plus 9 minus 10, that gives us 18 minus 10, 8. There's our winner. Okay, so the x minus 2x plus 5 is our original, and that is equivalent to that nice trinomial x squared plus 3x minus 10. So if we take and we could do a second one, okay, try 5, trying a different number. So do the same thing, plug it into the original. So we say 5 minus 2 times 5 plus 5, and we know that that's 3 times 10, which is 30. Go to the second expression and do the same thing. So if we take 5 squared minus 10, that's 25 minus 10, 15, clearly not equal to that 30. Okay, and the last expression, okay, that trinomial. So if I take, whoops, I'm going to go blue. 5 squared plus 3 times 5 minus 10, so 25 plus 15 minus 10, that's 40 minus 10, 30. So we've got two examples, okay, to prove to us that the quantity x minus 2 times the quantity x plus 5 is equal to x squared plus 3x minus 10. All right, so let's continue on. Okay, so it says it would seem that if you were just mindlessly manipulating the product of two binomials, then you would likely think two expressions were equivalent when they're not. Let's find out in the next exercises how to multiply out two simple binomials using a variety of properties. So when I look at my example, I've got x plus 3 times x plus 5. Write down the justification for each step. So here's my original in step 1. And then they go to and they say x plus 3 times x plus 3 times 5. So what's happened there? We have taken that binomial and multiplied it by x, and then we took that binomial and multiplied it by 5. Justification for that, which property is that? That is our handy distributive property. Looking at that next step, so this is where we left off. So they're saying, okay, we go down to this, and now we manipulate it, and what has happened? So we've got x times x plus 3 times x plus x times 5 times 3 times 5. So what has happened there? So we've just, again, x times x, 3 times x. Distributed that x to the x plus 3, and then we did the same thing with the 5. 5 times x, 5 times 3. So we've used the distributive property again. And this last step, let's see what happens here. So again, that is right here. How did we manipulate it? We got to x times x plus x times the quantity of 3 plus 5 plus 3 times 5. What has happened again there? And we've got the distributive property a third time. Okay? We end up with our final answer, okay, which is equivalent to, so we've got that two binomials. We end up getting that nice trinomial x squared plus 8x plus 15. So I like to call that double distributing, okay? Whoops. Double distributing. Like I said, I'm working on a new stylus here. I'll have to show you guys in class what I use. It's kind of cool. Okay? Alright, go ahead, flip the page. And, whoops, too many pages. Okay? It says, wow, that's a lot of justification. The process of multiplying binomials is pretty important in algebra. We're going to use it a lot. So you want to become fluent with it, meaning you want it to be very automatic. Keep in mind that you are simply doing the distributive property twice. Okay? So we want to take these two binomials and double distribute, and then our final answer is going to be a trinomial. So let's try that, that first one. And so x times x, x squared, x times 3, 3x, plus 6x, and then plus 18. Those are our like terms. X squared plus 18x. Whoops, not 18. Said combine, not multiply. So I end up with x squared plus 9x. That's a little bit more like it. 9x plus 18. Okay, here's our trinomial. Alright, let's try, I'm going to hop over to letter C. Let's look at that one. So again, just double distributing two binomials. X squared minus 3x minus 3x. Be careful with your signs. Plus 9. X squared minus 6x plus 9. Okay? And let's look at these down at the bottom here. Okay, now we've got some coefficients that go along with the x's. So instead of just a 1x, but we still do the same thing. 3x times 3x. 9x squared plus 6x minus 12x. Should go down below here. Minus 8. Those are your like terms. 9x squared minus 6x minus 8. There's your trinomial answer. Okay? By all means, practice on B, D, and F. Okay? Let's talk about checking these on the calculator. It's kind of neat to check them on the calculator. So let's check letter A on the calculator. So x plus 6 times x plus 3. So how do we check it on the calculator? So I'm going to go to my calculate page. And first of all, I got to assign a value to x. So I'm going to say x, and then to assign a value, we hit Control, and then the key that's next to the 9 key. We can pick any value. I always pick kind of a silly value, 12.3. It's all in the bottom row there, and 12.3 is my birthday, so I always pick 12.3, and then hit Enter. So that stores that value that we're going to use in the calculator. So now let's type in our problem. So the problem was x plus 3 times the quantity, oops, that was a 6 really first, but we know, I'm going to make sure that it looks exactly the way the problem looks, but we know that multiplication is commutative, so the order does not matter, but let's make it exactly the way the problem looks. Times x plus 3, okay, and a regular equal sign. Does it equal? Now let's type in the trinomial that we came up with when we double distributed. So we came up with x squared plus 9x plus 18. Okay, so the problem equaling the answer. And notice how the x is bold. When the x is bold on the calculator, that means that something is stored into it. So let's see that we did our double distributing correct. Hit Enter. True. Okay, so if you did something wrong in your multiplication or in the end when you're combining like terms, you would enter this in and you would get false. Okay, all right, so let's go back to our page. Okay, and let's continue on. It says, Jeremy has noticed a pattern that he thinks is always true. He picks a number, he picks any number and finds the product of one number larger and one number smaller than it. The result is always one less than the square of its number. Okay, so let's see what he means by that. So test some numbers out and see if Jeremy's pattern holds true. Okay, if he picks any number and finds the product of one number larger and one number smaller. Okay, so I don't know, I'm going to pick the number 8 just for kicks. Okay. So I've got to pick one number larger, so that's 9, and one number smaller, that's 7. And he says the result is always one less than the square of the number, the product of those two numbers. So product means to multiply. Okay, so we know 9 times 7 is 63. And he says the product of this is always one number less than the square of the number we worked with, we picked. So 8 squared is 64. Is that one number less than 63? Yeah, it sure is. I think that's pretty cool, but I wouldn't just go with one example. I don't know. Let's pick a negative number. Let's say negative 2. So one number greater, which is negative 1, and one number larger, or excuse me, smaller, which is negative 3. The product of those is positive 3. So now let's square that number. So we've got to square the whole number, okay, which is negative 2. Negative 2 squared, holy smokes, it's 4. Is that one number larger than what we came up with? Yeah, that's kind of cool. All right, so let's do some algebra with it. It says, give an algebraic example, explanation that shows that Jeremy's pattern will work for any number. Okay, so any number means x. Use the let statements to clearly define your variable. Okay, so let x equal a number. All right, so if x is our number, one number larger than x would be x plus 1 times, and then what's one number smaller than x? Well, take x and take 1 away. All right, we go through our double distributing. Again, we'd say x times x is x squared. Then we have minus x plus x minus 1. When we clean that up and we combine like terms, we have x squared minus 1. Does that fit what we talked about in A? If we took our number, which was x, and we squared it, okay, the prediction was that it would be, okay, our product would be 1 less than the square of our number. Isn't x minus 1 1 less than x squared? My mind was blown when I saw that. I don't know about you guys, but I thought that was pretty cool. All right. I'm going to give you the answer to this one. By all means, multiply it out, test it, check it on your calculator. But we've got to go on and look at the next lesson. All right, so if we scroll ahead, okay, so more structure. Okay. The more you're able to see structure in various expressions that you deal with, the easier it will be to manipulate complex expressions. So structure, you look for patterns. We can now look at some larger structural issues that include equivalency. So now let's just kind of complicate this a little bit, and let's look at that expression. Okay. It says, write an equivalent trinomial expression, test the equivalency with a value x equals 1, show the test. So I'm going to go up here and just to give me some space to write. So x plus 4, whoops, plus 2 times x plus 4. So distribute x squared plus 4x plus, now I'm going to distribute the 2x plus 8. Combine any like terms, x squared plus 6x, okay, plus 8. So they said to test 1, okay. So if we test 1 in our original, okay, we end up with, let's bypass that. We're running out a little bit of a space. Go ahead, test 1 on your calculator. Store 1 into your calculator. And then go ahead, type in the expression, and then type in the trinomial that you came up with, and see if they are equal. Okay. So it says, write an equivalent expression that is in the form of the product of 2 binomials. Also test the equivalency. Well, what are they talking about there? Write an equivalent expression, okay, that is in the form of the product of 2 binomials. So we need, they're saying, okay, so go with that original expression, this one right here. Could we write that as the product of 2 binomials? So what do we see here? What's in common with these? I see x plus 4 is in common. Okay, that's a greatest common factor. Wow. And then what's left over? X plus 2. Okay, so I guess we should test. Let's put that 1 in. So 1 plus 4. And then 1 plus 2. That's going to give me 5 times 3, which is 15. Let's see if this one over here equals 15. 1 squared plus 6 times 1 plus 8. Okay, so I've got 1 plus 6 plus 8. Holy smokes. 15. Wow. Okay, we've got 3 different looking expressions. We've got the one that was given to us. We've got this trinomial. And then we've got this binomial. These, all 3 are equivalent to each other, but look very different. I think that's kind of cool. Okay. So it says, consider the expression, write an equivalent expression that is in the form of the product of 2 binomials. Test the equivalency with a value of x. Show your test. So I look at this expression, look for something that is in common. What do you see that's in common? We've got these two binomials times these two binomials. So what's in common? X plus 4. That is a greatest common factor. Okay, if we divide those out, essentially that's what's happening. And then, whoa, what do we got going on here? We've got x minus 5 plus x minus 2. Now that kind of looks like a mess because I got those big parentheses and then I've got little parentheses inside them. But what's going on inside here? Think of your order of operations. We've just got addition. So just combine like terms here. So we leave that x plus 4 out in front. And if we clean this up, what's x plus x? 2x. What's negative 5 plus a negative 2? It's negative 7. So they're saying to test your value, test the equivalency of the with a value of x, we absolutely could go to the calculator, okay, real quick and do that, or we can do that by hand. So if I go to my original and put in, okay, this is back into the original problem, 1 plus 4, 1 minus 5. Let's see if I can move this over. Give myself a little bit more space. Okay, there we go. Plus 1 plus 4 times 1 minus 2. Whoops. So simplifying, 5 times a negative 4 plus 5 times a negative 1. So that's negative 20 minus 5. So that's saying that that's equal to negative 25. Let's do the same thing into the answer that we came up with here, with the product of these two binomials. So 1 plus 4 times 2 times 1 minus 7. By all means, go to your calculator here. So we've got 5, and then we've got 2 minus 7, which is negative 5. Holy smokes, there it is again, negative 25. Yes, those are equivalent. This answer, okay, looks clearly different than the problem they gave us, but they are equivalent. Okay, so let's look at this multiple choice question. And we have, again, look for what's in common. Looking at that, what do they share in common? They share an x minus 3. That's our GCF. Okay, essentially we are undistributing here. Okay, I'm going to use bracket. Okay, you could just use a bigger parenthesis. It doesn't matter. So what's left? Oh, don't forget that's a minus there. X minus 4. And I'm going to close up that bracket. Now, x minus 3. Clean this up. Now be really careful because that's a minus sign there. Okay, you've got to be super careful. I like to call that the gatekeeper. You got to go through the gatekeeper to get to the other side. So 2x minus x. 2x minus x is x. But then I've got to say negative 7 minus a minus 4. Negative 7 minus a minus 4 is plus 11. Okay, so x minus 3 times x plus 11, that ends up being choice number 2. Okay, all right, go ahead, flip the page. All right, we've got some more practice with this. Okay, I'm going to put up the answers here because we are getting a little lengthy, and I apologize. So I'm just going to kind of go through rather quickly and put the answers in for you. So I'll give you a few of them. So we have x plus 5 is what's in common. X plus 7 is what's left over. X minus 2 is what's in common. What's left over? 3x minus 4. Okay, these are all equivalent expressions. Now this one looks a little bit different, but if I just put parentheses around that, what's in common? X plus 4. Then you might say to yourself, well, what's left over? I see negative 2x, but what's really in front of that set of parentheses? It's a plus 1. Okay? Letter D, you could say that there's what's in common. X plus 3. Oh, we got a lot left over. We've got x minus 6 and x plus 9. Sorry, that's my dogs. That's Lola and Louie. Those are my two dogs. So x plus 3. Let's clean up what's inside the parentheses. 2x plus 3. Okay? Get the idea on that? I think you do. Okay? And I will pause it there and be done. Not going to kill you with this. By all means, take a look at any of the ones that we didn't do. Take a look at exercise 5. I will tell you that the final answer in exercise 5 is 63. All right, guys. Thanks.